Imagine, you're living 12,000 years ago. It's getting warmer, the glaciers are retreating, and hope for a stable future blooms. Then, bam! The Earth throws a curveball, temperatures plummet, glaciers surge back, and you're thrust into a mini ice age. That's the Younger Dryas, a 1,300-year blip in history that shook humanity and the planet. Welcome to a journey back in time, to an enigmatic episode that has kept scientists and archaeologists intrigued for decades. The Younger Dryas period. It's an epoch that feels as though it is pulled straight from an intriguing detective novel, filled with clues, riddles, and an underlying mystery that's yet to be fully solved. This period, named after the alpine tundra wildflower Dryas octopetala, is a chronozone, a specific interval of geological time that occurred approximately 12,900 to 11,600 years ago. It sits on the cusp of two significant epochs, the Pleistocene and the Holocene. The Pleistocene, often referred to as the Ice Age, was a time of extensive glacial coverage. The Holocene, on the other hand, is the epoch we're currently in, characterized by a warmer climate that has allowed human civilization to flourish. But the Younger Dryas period is a conundrum. It was a dramatic and abrupt return to glacial conditions within the mild interglacial period. Imagine, if you will, a sudden plunge in temperatures, a cold snap that lasted over a millennium, right in the midst of a warming trend. This climatic flip-flop has been a subject of intense study and debate among scientists, and yet the cause remains shrouded in mystery. Was it due to a sudden influx of fresh water into the North Atlantic, disrupting ocean currents and thus the global climate, or perhaps a cosmic event such as a comet impact causing a global winter? These are but a few of the theories that have been proposed and scrutinized. As we peel back the layers of this fascinating period, we will delve into the various scientific and archaeological evidence that has been unearthed. From ice cores to fossils, from geological formations to archaeological findings, each piece of evidence adds a new dimension to our understanding of the Younger Dryas period. So let's delve into the scientific evidence that archaeologists have uncovered about this intriguing period. The secrets of the Younger Dryas lie locked in the world's ice. This statement, my friends, is far from hyperbole. These colossal ice sheets of Greenland and Antarctica have for millennia silently recorded Earth's climatic history. The key to deciphering them? Ice core records. Now, what makes ice cores so valuable to paleoclimatologists, you ask? Well, they are essentially troves of climatic data, patiently waiting to be unlocked. The process is akin to peeling back the layers of an onion, each layer representing a year, a decade, a century of our planet's past. This discipline, known as stratigraphy, is fundamental to understanding these frozen archives. Imagine, if you will, an ice core sample drawn from the very depths of a Greenlandic glacier. Each layer within this sample contains tiny bubbles of air, trapped as the snow compacted over time. These microcosms of our past atmosphere hold key information about temperature, precipitation, and even the composition of the atmosphere at the time they were captured. Isotopic analysis plays the starring role here. By studying the ratio of different isotopes of oxygen and hydrogen in the ice, scientists can deduce the temperature when that layer was formed. A higher ratio of heavier isotopes indicates a warmer period, while a lower ratio suggests a cooler climate. Now, let's journey south to the icy wilderness of Antarctica. Here, ice core records mirror their Greenlandic counterparts, but with a twist. Antarctic ice cores can reach back even further, some more than 800,000 years, offering a more extended chronology of Earth's climate. But our journey doesn't end there. These ice cores also contain traces of volcanic ash, pollen, and even microscopic life forms, offering additional insights into the Earth's climatic and ecological history. So, you see, these ice cores are more than just frozen water. They're time capsules, a testament to Earth's climatic past. Each layer, each bubble, each grain of pollen tells a story, a chilling tale of climatic ebb and flow. The fossilized remains of Flora and Fauna offer another intriguing piece of the Younger Dryas puzzle. As we delve into the realm of paleobotany, the study of ancient plants, we unearth clues about the climatic conditions during the Younger Dryas. Fossilized plant species from this period, preserved in nature's time capsule, provide a snapshot of the planet's vegetative state. Leaf morphology, seed characteristics, and even the type of wood all whisper tales of the past. The presence of certain species that thrive in cold conditions, for instance, are a testament to the dramatic temperature drops of the era. Let's step into the world of palynology, where we study fossilized pollen grains. These microscopic structures are incredibly resilient, surviving even the harsh conditions of the Younger Dryas. The variety and abundance of these grains offer insights into the floral diversity of the time. A sudden increase in spruce pollen, for example, indicates a rapid encroachment of spruce forests, a response to the changing climate. Now, let's not forget the fauna. The study of animal fossils, or taphonomy, provides a complementary perspective. The Younger Dryas saw a notable extinction event, particularly in North America, where many large mammals such as the woolly mammoths and saber-toothed cats met their end. The analysis of these fossils, from the type of species to their geographical distribution, hints at the possible causes of their demise. Was it the sudden climate change, or perhaps competition with the newly arrived human populations? A particularly fascinating aspect of taphonomy is the study of fossilized insect remains. Insect species are highly sensitive to environmental changes, and their fossils can reveal a lot about the ecological conditions. A surge in beetle species that prefer a cooler climate, for example, corroborates the evidence of a sudden chill during the Younger Dryas. Indeed, the fossilized remains of flora and fauna are no mere relics of the past. They are a treasure trove of information, a biological record of the Earth's history. Through the lens of paleobotany, palynology, and taphonomy, we can reconstruct the climatic and ecological narrative of the Younger Dryas. These remnants from the past paint a vivid picture of a world in transition. The Earth itself bears the scars of the Younger Dryas period. Each crevice and chasm, each hillock and hummock is a testament to the capricious dance of climate during this intriguing epoch. To decipher this geological cipher, we delve into the realms of geomorphology and sedimentology, the study of landforms and the processes that shape them. Let's consider glacial till, a jumbled, unsorted mix of rocks, boulders and sediment deposited by a glacier. The distribution of glacial till across vast stretches of the northern hemisphere is a compelling testament to the expansive ice sheets that once covered these lands during the Younger Dryas. In regions such as New England and Scandinavia, we find moraines, ridges of debris deposited at the edge of a glacier. These moraines, like frozen waves etched into the landscape, give us clues about the extent and movement of glaciers during this period. The Younger Dryas saw glaciers advancing and retreating in a climatic ballet, choreographed by shifts in temperature and precipitation. But the evidence doesn't stop there. The Earth's crust, akin to a buoyant raft floating on the denser mantle below, responds to the weight of ice through a process known as isostatic rebound. As ice accumulates, the crust sinks, and as it melts, the crust rebounds or bounces back. This slow seesawing movement of the Earth's crust is a further testament to the vast ice sheets of the Younger Dryas. And then we have the sedimentary records. Layers upon layers of sediment, each a page in Earth's geological diary, reveal shifts in erosion and deposition rates, changes in grain size and variations in mineral and organic content. These changes are tied to the climatic oscillations of the Younger Dryas, painting a picture of a world in flux. So, as we traverse the Earth's surface, we walk on a tapestry of geological evidence. Each glacial till, each moraine, each subtle shift in the sedimentary record, and every undulation in the Earth's crust speaks to the dramatic climatic shifts of the Younger Dryas. These geological markers stand as silent testimony to a turbulent time in our planet's history. The traces left by ancient human societies offer a tantalizing glimpse into life during the Younger Dryas. Let us delve into the labyrinth of time and unearth the archaeological evidence from this mysterious period. Diving into the realm of lithic analysis, let's consider the changes in tool use. Prior to the Younger Dryas, humans were known to use a variety of tools, but as the climate became harsher, we observe a significant shift. The tools became more specialized, an adaptation to the challenging environment, no doubt. Spear points for hunting, scrapers for skinning animals, and drills for making clothing and shelters became common. The need for survival was driving innovation. Consider also the settlement patterns of the period. The onset of the Younger Dryas saw a significant transformation in human habitation. As the lush landscapes turned into icy tundras, humans were compelled to abandon their nomadic lifestyle. They began to establish more permanent settlements, often near water bodies, a clear indication of their adaptation to the severe climatic conditions. Turning our attention to archaeozoology, we discover the bones of extinct megafauna like the woolly mammoth, which were hunted by humans for their meat and hides. These archaeological findings provide compelling evidence of the struggle for survival during the Younger Dryas. Through the lens of cultural stratigraphy, we can see the layers of human activity during this period. Each layer, a snapshot of time, reveals a story of human resilience and adaptability. The distinct layers corresponding to the Younger Dryas period show the impact of the climatic changes on human societies, their tools and their settlement patterns. While the exact culprit remains elusive, several contenders hold compelling evidence for triggering the Younger Dryas cold snap. First, we have the freshwater deluge. Meltwater from collapsing ice sheets, particularly a massive outburst from Lake Agassiz, could have disrupted the Atlantic meridional overturning circulation, slowing heat transport to the north. However, recent studies question the timing and volume of such discharges. Secondly, a volcanic tantrum. Large volcanic eruptions spew aerosols, reflecting sunlight and cooling the planet. Evidence of eruptions around the Younger Dryas timeframe exists, but their precise impact is debated. Third up, a cosmic encounter. Some propose a comet or asteroid impact, injecting dust and soot into the atmosphere. While intriguing, definitive proof for such an event remains elusive. We hope you enjoyed that journey into our planet's mesmerizing past. Do like this video and subscribe to Sci Sips for more.